Next, we'll be looking at how to factor something of the form ax squared plus bx plus c. We're going to use what's called the grouping method. There are other methods that you might see in later courses, but we're going to start with grouping method. The first step of grouping method is to identify the values that you've got plugged in for a, b, and c, and then you're going to take the values for a and c, you're going to multiply them, and then you're going to figure out what numbers you could think of that multiply to that answer of a times c, but add up to the value of b, that middle number. Once you have thought of those two numbers, you're going to replace the middle term using those values. So let's say the middle term was a 5x, and you came up with 3 and 2 that added up to 5. So you would take out the 5x and you'd put in a 3x and a 2x, which still equals 5x. You're just substituting something equivalent to it. Once you've done that substitution step, you're going to have 4 terms in your new expression. You're going to group those into groups of 2. So the first 2 terms will get grouped together, and the second 2 terms will get grouped together. From there, you're going to take out GCFs from both sets of 2. And when you're done with that, you should have a common binomial that you can factor out, and then that would give you your final solution. So let's try some examples. Let's start with x squared plus 13x plus 40. So the first thing I would do, I'm going to be comparing this to ax squared plus bx plus c. And in that first example, my a value would be 1. My b value would be 13, and my c value would be 40. And I'm supposed to find 2 numbers that multiply to ac, but add up to b. Now ac would be 1 times 40. Here's a, here's c. 1 times 40 is 40, and my b is 13. So I would have to brainstorm all the things I could think of that multiply to 40 until I find the ones that add up to 13. I find it useful, if I can't think of it after a few seconds, I find it useful to start making a list. So start at 1 and then work your way up. 1 times 40 is 40. 2 times 20 is 40. There's nothing, 3 times something doesn't equal 40. You can't do that with integers. 4 times 10 is 40. 5 times 8 is 40. There's nothing that works with a 6. You can't do 6 times anything and get 40. There's nothing that works with a 7. You can't do 7 times something and get 40. And then the next number on my list would be an 8. But 8 is already in my list. So this is how I know that I'm done. I've come up with all the different factors of 40. Now I'm going to go back and see what they add up to. I have ones that add up to 41, 22, 14, and 13. And I wanted the ones that added up to 13. So I want the 5 and the 8 for this question. So the next step, after I found the 2 numbers that multiplied to AC and added up to B, my next step was to replace the middle term with those values. So I'm not going to be changing the x squared. I'm not going to be changing the 40, but I'm going to be changing the 13x into 5x plus 8x. Now, if you decided to write 8x and 5x like you switched them, that's okay too. Addition is commutative. You will get the same solution in the end. Right, our next step was to group these 4 terms into groups of 2. The first 2 will go together, and the second 2 will go together. The next step is to take these new groups and treat them as GCF problems. So my first group, x squared plus 5x, that has a GCF of x. After I factor out the GCF, I kind of do reverse distributing to figure out what goes in the parentheses. So I ask myself, x times what equals x squared? X times x equals x squared. X times what equals 5x? X times 5 equals 5x. Copy my plus sign in the middle. Now I've got to figure out 8x and 40. What do they have in common? They have a GCF of 8. Then I ask myself, 8 times what equals 8x? 8 times x equals 8x. 8 times what equals 40? 8 times 5 equals 40. Now this is a place for you to kind of check your work. We're just about done. But if this has been done correctly, these two binomials should be the same. If you've gotten to this point and you got two different things, like maybe one was an x plus 5 and one was an x minus 5, or maybe one was an x plus 5 and the other one was an x plus 3, that means that you made a mistake someplace along the line. Or it might also mean that this could be prime, possibly. Our last step was to factor out the common binomial. So we're going to factor out the x plus 5 from both of these terms. Here's my first term. And when I factor out the x plus 5, there would still be an x left over. So I've got an x over here. And for my second term, here's my second term. And when I would factor out the x plus 5, I'd still have an 8 left over. I've got this plus and then the 8. So then here would be a plus 8. So my final solution is that x squared plus 13x plus 40 factors into x plus 5 times x plus 8. Remember, you could check your work by taking your solution and multiplying it out. And if I've done this correctly, I should get the original problem. Remember that factoring is just the opposite of distributing, and I do. So I know that that solution's correct. You can kind of almost see some of our steps in our work here. You might remember how we ended up with the 8x and the 5x there in the center. So you can see how they're inverses.